Hi, I'm Peter Zanik, and today I will talk about why we parse log messages. So let me give you a quick overview. I will start explaining why we really need to parse log messages, how it can help us. I'm coming from the Syslog-ng team, so I will give you a short introduction to Syslog-ng, and I guess many of you who were here in previous years, it will look familiar to you. But I try to make sure that my talk is not completely Syslog-ng specific, but also about general log management. I will also introduce you to Sequence, a very interesting application developed by one of our users. And finally show you a couple of uses for name value pairs, the results of message parsing. So what is logging? It's a recording of events on a computer. I guess this log message will look familiar to most of you. It's an SSH login message. And we are coming to, right to the heart of the problems of logging free-form log messages. As if you look at syslog messages or anything in the most of the log messages in the journal, it's no difference. You will see that it's a date, a host name, and some text. And the text part is often an almost complete English sentence. With some variable parts in it, which is pretty easy to read by a human, and it was intended to be read by humans. I recall that 30 years ago when I was running my first servers, each day when I went to the server room, I read all the 30 messages collected by the actual syslog implementation. There were really just a couple of dozens of messages each and every day that was easy to read and act on. The problem is that nowadays 30, 50 messages are generated every minute or even each and every second, which are just impossible to follow as a human being. So you need to create alerts, you need to create reports on your log messages, but if these are free-form log messages, long complete English sentences, then it's really very difficult to create any alerts or reports on your log messages. There is a solution for this problem. It's called structured logging, and it has many formats, but it boils down to a simple concept describing events as name value pairs. For example, an SSH login can be described as an application equals the SSH daemon, the username equals root, source IP address, that it's a login action, and if it was successful or a failure. Here you can see a couple of log messages on screen, and the first one is the good old SSH login message collected through Syslog, but there are already a couple of structured log messages. The second log message on screen is an Apache access log. You see that it has some columnar data in it. And the third one is a JSON formatted log message created by sudo. There is one little problem. These are just long strings from the logging point of view, as long as you do not parse it. There are many parsers for log messages in Syslog-ng and in most other log management applications as well, especially for structured log messages. These parsers create name value pairs from interesting message parts. And there are parsers for structured logs like CSV parsers, like the Apache log format, or JSON, XML, key value pairs, and so on. Syslog-ng also has a technology called pattern-db, which you can use to parse free-form log messages like the SSH login message I mentioned a couple of times. And you can also combine parsers to parse really complex log formats. And these are included in the Syslog-ng configuration library, or SCL, for sudo, Apache, and Cisco. Cisco log messages are, in theory, syslog messages. In practice, they just resemble syslog messages and really difficult to work with. And we can enable parsing these log messages automatically on some of our inputs. So why name value pairs are so important? If you have just a huge long string, then you cannot really use that in any way just to store it or forward it somewhere. But if you have important parts parsed from it, then those small pieces of information can be used in multiple ways. The first one is filtering or message routing. So you can use filters to make sure that all of your authentication-related events reach your SIEM system for further analytics. But you can also use filtering to discard any surplus log messages. Another use of name value pairs is log storage. If you have name value pairs instead of long strings, then you can easily reformat these logs for the requirements of the given destination, like Elasticsearch expect log messages in JSON formatting, and there are many similar requirements for other applications. And the other use is that you save or forward only a small part of the message, the really interesting information. For example, if you want to create an alert from the previously shown sudo log message, you do not want to have that JSON log message showing up in your Slack or Telegram as a real-time alert, but only a username and an application name, what the user is trying to do. Or you can save lots of network and storage resources just by making sure that only relevant information is forwarded. One of our users explained that they are saving terabytes of network resources and storage each and every day just by making sure that they forward 2-3 name value pairs from a multiple kilobyte long log message, which means also saving many thousands of dollars each and every day on networking and storage. What is Syslog-ng? It's an enhanced logging daemon with a very strong focus on portability and high-performance central log collection. Portability means that you can use it on any architecture supported by openSUSE, big endian, little endian, and high performance means that it is really optimized for collecting hundreds of thousands of messages each second. Syslog-ng is developed in C, but now it can be also extended in C++, Python, and Java as well. It has 4 major roles: collecting, processing, filtering, and storing log messages. collecting system and it can collect system and application logs together, which can provide quite useful contextual data for either side. It can receive Syslog messages over the network using the legacy and the new Syslog protocol using UDP, TCP, and encrypted connections. It can also collect logs or any kind of text data from applications. And if none of the ready-to-use log sources are suitable for you, you can easily extend Syslog-ng yourself using Python. The next role is processing log messages. You can use Syslog-ng to classify, normalize, and structure logs with built-in parsers. I mentioned already some of these. And you can also rewrite log messages, and you do not have to think about falsifying log messages here, but there are quite a few compliance requirements where you have to anonymize log data like credit card information and stuff like that. You can also enrich log messages using GIP. You can add location information to IP addresses. You can reformat log messages, like I mentioned, that Elasticsearch needs ISO date and JSON formatting. And if none of the above possibilities are good enough for you, you can write your own parsers in Python as well. The next role is filtering. I already mentioned a bit of this. Most people just think about discarding the surplus log messages, as you do not want to store debug level messages unless you really need it for some debugging sessions. But the more important, at least in my view, is message routing, making sure that your log messages reach the right destination. There are many possibilities in filtering. It can be based on message content, various message parameters. You can use comparisons, wildcards, different filtering functions. And best of all, the possibilities are endless, as you can combine these using Boolean operators. Finally, you have to store log messages somewhere. Traditional log messages were saved to text files or forwarded using one of the Syslog protocols and saved to text files at the destination. There are many more possibilities now. We can send logs to various SIEMs and log analytics systems, store logs to various databases, even to Hadoop file systems, various document stores like Elasticsearch, MongoDB, message queuing like Kafka, and some others. You can write your own destinations. If it has an HTTP API, then using the wrapper around the HTTP destination, or write your destination in Python or Java as well. I already mentioned PatternDB. It's a parser for free-form log messages. Obviously, it doesn't know log messages by itself. It needs an XML database to describe log messages. It's using this database to parse the log messages. The PatternDB parser is a lot more efficient than using regular expressions from the resource usage point of view. And it's also slightly less painful to write the rules for PatternDB than for regular expressions. It's an XML, and no comments on that one, as it's for many people it's a love-hate relationship. But this format allows us to not to just include rules, but also sample logs and test data, which can be quite useful. And as you know, as you have the log information at hand, you can also give also create some additional name value pairs based on the message content. Like if you recall my SSH example, that it's an action equals login, status equals failure. It's not written in the actual log message, but you can create similar name value pairs based on the message content. And you can also create simple correlation rules in PatternDB. PDB tool is bundled with Syslog-ng, and it allows you to test the file structure and the parser rules. So you do not have to load the rules into Syslog-ng just to test the rules, but can easily test using PDB tool. Here is an example XML. It's a rule for PatternDB. I marked the actual rule with bold. You can see that it's a lot more easy to read and understand than a regular expression. Just looking at it, you see that there are some fixed tests, some strings with a name attached to it, or yeah, all of these are strings as far as I see. And below that, you can see an example log message and some test values for that to test the parsing rule. And here you can see that we can also add name value pairs from the XML rules, like that it was a login action and it was accepted, or it was successful. Writing PatternDB rules is a lot more easier than writing regular expressions, but still it's work. And if you have lots of log messages, then it's lots of work. Here is where sequence can help you. It's developed by one of the power users of Syslog-ng. It can generate PatternDB rules and also regular expressions for LogStash from reading logs, many logs. It needs thousands of log messages as input, and its precision depends on the amount of log messages. However, if you have many logs, then you can easily create parser rules for most of your log messages. And it has some hints built in, as one of the problems with name value pairs that you actually need to name them. And there are some hints for naming built into sequence. Of course, the results need some review. Some brave people use the output of sequence in production as they are created, but normally you review these rules, you delete some badly written rules, you edit other rules to give proper naming for the name value pairs. But it's still a lot faster than writing rules from scratch for your log messages. Sequence is developed in Go, and right now it's available on GitHub. There is no package for sequence available yet, but once I'm back from various conferences, I plan to work on this. So expect to have working package for sequence before the end of the summer. I already mentioned naming a couple of times. It's a real pain when it comes to logging and name value pairs, as there are many standards, which means that there is not a single standard accepted by everyone. If you name your name value pairs according to one standard, then another application will not like it. Like there are separate naming standards for Splunk, for Elasticsearch, for ArcSight, for whatever else. So it's up to you which one you start using when naming your name value pairs. Finally, I want to show you configuring Syslog-ng and using the name value pairs parsed from log messages. So let me give you a very quick introduction to configuring Syslog-ng. You start the configuration with a version number declaration. Well, actually, it's a really old example as far as I can see, as 3.23 is a couple of years old. But this versioning ensures that if you upgrade Syslog-ng to a later version, then all of Syslog-ng will still work as expected, and the changes will not break how Syslog-ng works. And then it will print some recommendations how to change your configuration to work better with the up-to-date Syslog-ng version. You can also include other configurations. I already mentioned the Syslog-ng configuration library, which is a collection of configuration snippets you can use, like the Elasticsearch destination or the pseudo parser are defined in the Syslog-ng configuration library. These are not features which are defined in the C code. Next, you can see various Syslog-ng building blocks, like a source, a destination, and the filter. Usually, the thing is that you declare what kind of building block it is, then you name it, and then you list the drivers you want to use. So there is a source called sys, and it's using the system for collecting local log messages, using internal for internal Syslog-ng messages. Then there is a destination called messages, which and it's a file destination writing to var log messages, but not simply that one. But here we use information extracted from log messages, name value pairs, the name of the month, the name of the day, and we could also use here a username or IP address or whatever else extracted by various parsers from log messages. Next, we have a filter, which is typical for var log messages, and finally there is a log statement. This is a kind of heart of the Syslog-ng configuration, as log statements connect the various building blocks we defined earlier. So here you can see that we list here the source, the filter, and the destination in this log statement. And you can use all of the previously defined building blocks multiple times in your configuration. Here you can see a few more building blocks defined. In this case, I collected log messages from Windows clients using the new Syslog protocol. I used an XML parser on the Windows log messages and PatternDB to find some information in one of the log messages. Here we define an Elasticsearch destination, and you can see here yet another template where we use name value pairs. In this case, we include. In this case, we use JSON formatting, as that's what Elasticsearch is expecting from us, and we include all of the Syslog-specific name value pairs and any name value pairs we parsed from the log messages. And finally, we also replace the traditional Unix date format, Syslog date format, with ISO date, as expected by Elasticsearch. So templates can be quite powerful. Here, on the upper part of the screen, we have a file destination where we write log messages 2 times. The first one is a simple syslog file destination without any extra formatting. The second one is using the same JSON formatting as on the previous screen in the Elasticsearch destination. At the bottom of the screen, we have a Slack destination for real-time alerting when there is something interesting happening on our network, as found by the pattern-db parser. And here, instead of sending the whole log message as received by Syslog-ng, we only send the parsed information to Slack, as it's much easier to read than a long log message. And here we can see yet another log path where we connect all of the previous building blocks together. The log source, then we check the name value pair for the application name and use the XML parser only if the log message is not coming from Syslog-ng. We use the pattern-db parser to check the message if it's a specific connection message, and we parse out a few interesting information from these log messages. And at the bottom of the screen, the next bold type part is that we check if the name value pair exists, and if it exists, then we create a entry in a log file and also send the results to Slack in real time as soon as we detect that log message. Finally, we save all of the log messages to files and Elasticsearch. Here you can see that the alerts by Syslog-ng arrived in Slack. So let me summarize my talk. Structured log messages make life a lot more easy, but unfortunately free-form log messages are here to stay for a long time. Most log messages can be parsed and turned into name value pairs by Syslog-ng or most other log management applications. And these name value pairs can make sure that the right log messages reach the right destinations in the right format. And I mentioned that free-form log messages are quite problematic to work with, but using sequence, you can easily create rules to parse even free-form log messages in a semi-automatic way and make your job a lot easier. Thank you for your attention. Do you have any questions?
It looks quite powerful what you can do with all these configurations around there. When you build up a lot of big parser for parsing all these messages to a high level, doesn't that impact the overall performance of Syslog-ng? I think the more you define, the more it may impact the performance, or not?
Yes, that's right. Normally, it's not a problem. I mean, even on a Raspberry Pi with the parsers enabled, you can easily collect over, and that was a Raspberry Pi 3 where I measured over 60,000 messages. And on talking to users, the average message rate they collect is below 1,000 messages a second. So normally, it's, using parsers is not a limitation. Obviously, when you have a large network and collect hundreds of thousands of a second, then it's better if you make sure that you only enable the parsers you really need. And also there are possibilities that you use a central server, but you have relays between your clients and your central server. So the relays do the processing, filtering, whatever, and your central server only does the collecting and saving. So there are many ways to work around the performance problem.
Okay, thank you.
Thank you.